All right, welcome. We'll get started in about a minute. Thank you for joining. All right, welcome everybody. Welcome to today's educational program, Smart Building Cybersecurity as a Service, brought to you by IIoT World and sponsored by Tempered Networks. I'm Lucian Fogoros. I'm the co-founder of IIoT World. On behalf of my team and my partners today, thank you for joining. Our co-founder, Carolina, will monitor our online channel, so feel free to send your questions either on the Q&A section or via the social channels, leveraging the hashtag ICS_IIoT. I'd like to introduce our moderator for today, Greg Orloff, our CIO and senior analyst, who will host our virtual conference. So welcome, Greg.
Thank you, Lucian, and hello, everyone. Good morning, good afternoon, and good evening, wherever you happen to be around this lovely planet. Before we get into today's session, please allow me to give you, and those of you that are joining us for the first time, a little background. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial IoT. IIoT World was recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Our mission is to help companies create a culture of innovation that connects the smarts, industrial technology, manufacturing, sensors, and the CXO decision makers who seek these solutions. For today's virtual conference, we have some truly interesting content to share from Grosvenor Engineering Group and Tempered Networks. Nicholas Lianos, Managing Director of Grosvenor Engineering Group, was recently quoted as stating, "The advent of IoT technologies is accelerating with the collection of data, enabling greater insights into how buildings operate. Comprehensively interpreting data can highlight possible failure points, identify where opportunities may lie to improve the indoor environment, reduce absenteeism, improve productivity, and decrease costs such as maintenance, energy, insurance, and employee-related." The question is how to secure all these future connected buildings. 50 years ago, when engineers invented the networking technologies that ultimately became the internet, they never imagined the billions of devices we use today. They introduced something that turned out to be a huge critical assumption, the fatal flaw, the IP address. Tempered Networks announced recently a new technology that fixes the fatal flaw, an Airwall. Airwalls don't use IP addresses for identity. No IP address means you can't find it. If you can't find it, you can't hack it. If it can't be hacked, your cyber risk goes down, way down. In this webinar, Tempered, a cyber risk management company with solutions that cloak IIoT networks, together with Grosvenor Engineering Group, a leading building services provider with over $2.2 billion of assets under management across 20,000 sites, will talk about a massive Airwall project. Key topics our speakers will cover today include smart building cybersecurity, unique risks and challenges, how to deliver real business outcomes to building owners using Airwalls, how to eliminate remote attacks, including lateral attacks that easily evade firewalls. We'll also touch on what is an Airwall, an air-gap firewall, and how this helps protecting smart buildings. We will also hear a customer story of Grosvenor Engineering Group deployment, a 10,000 plus buildings. It's always interesting to hear how other folks have done it. Our first session, entitled Cybersecurity as a Service, will be presented by Nicholas Lianos, Managing Director of Grosvenor Engineering Group. Nicholas has envisioned and guided the growth of Grosvenor Engineering Group with his partner, Peter Soufflias, for over 20 years into a position where the company is now one of Australia's preeminent providers of technical asset maintenance services, with an emphasis on HVAC, fire, and electrical services. Nick is passionate and driven in his desire to provide the best outcomes for clients by adding value to buildings by making them safer, more comfortable, productive, and energy efficient. As a leader, Nicholas works collaboratively with his senior executive team, Grosvenor employees, clients, and other stakeholders alike with the clear aim of establishing and maintaining productive relationships that inspire optimal results and exceed client expectations. Nick, we're anxious to hear what you have to say. The floor is yours.
Greg, thanks for that. And I hope everyone gets past the accent. So apologies if it's a bit confusing, but I'll do my best. Greg, I'll just go through my slides now and kick off. I've got the screen, I'm assuming. Okay, great. Morning, everyone. As Greg said, I think there are three key issues that I'm going to talk about this morning. One is, why do we want our buildings to get smarter? Why we need to solve the operational cybersecurity problem in order to make our buildings smarter? And why would we consider delivering cybersecurity as a service? So they're the three main points that my talk will address this morning. Now, essentially, if you look at the world and how we're evolving, building occupants expect more than ever before. Customer experience is king, which essentially means we need to have all the operational technology in the building be connected to the internet to allow it to become far more responsive to occupant needs. And if you have a look, I've got a little graphic that's going to pop up now that shows you the operational technology that a building would traditionally have in order for it to be livable, to be safe, to be occupied. And the reality is, when all these operational technologies were put into buildings, they were not connected to the internet. There was an air gap, essentially. If you wanted to get control of these technologies in a building, you'd physically have to walk up to the building, go into the engineer's office, access the computer, and do whatever controlling you needed to do. But because occupants are expecting more, the first change that happened, and this started happening about 10 years ago, 15 years ago, is that most of these systems started being connected to the cloud. So straight away, we started seeing a reduction or a breaking down of the air gap that used to traditionally exist with operational technologies. Now, the thing is that as the customer experience has become king, we've now added even more operational technologies into the building in order to enhance the customer experience. So you can see on this particular screenshot, we've got 26 different types of operational technology. The most recent building that we've been involved with has 41 different types of operational technology. That means 41 different suppliers essentially needing to access the building as well remotely. And this sort of brings me to my next slide. Just as property occupants are demanding more, that means property owners are demanding more from vendors like ourselves. And what that means is that they're looking for us to provide data-driven maintenance, for example, extracting data from the building, identifying which assets are getting sick. So when we walk into the building to do our maintenance, we're only focusing on the sick assets. We don't need to focus on the healthy assets. Now, if you have a think about that, that's also meaning that our tradespeople are becoming building doctors now. Just like doctors, because they're using analytics and we've got remote connectivity to the buildings and we understand which assets are getting sick, we can focus our technicians to essentially only go up to sick assets. But all of that productivity enhancement is only possible because of remote connectivity to the building. So if you look at these three diagrams, on the extreme left, we have the old world. We have operational technologies in the building and they're all air gapped and there's no connection to the internet. Then if you go to the middle, we have a building that has operational technologies, but now they're all individually connected to the internet. And all of a sudden we have a lot of vendors remotely accessing the technology in order to become more proactive in managing the technical assets in the building. That's the real world, that's today's world. And then over on the right, we have an integrated communications network. Think of a fiber backbone throughout the building, and the operational technologies are now connecting to that backbone, and through that one access point, they're going to the cloud. But again, you have many, many vendors connected to that building remotely. Now, the challenge is this: because the culture of our industry in terms of operational technology was there's an air gap, there is no cybersecurity concern. The operational technology world is nowhere near as focused on cybersecurity as the information technology world. But all of a sudden, now that we're remotely connected and the IT world is merging with the OT world, what we're finding is that the same cybersecurity risks that used to exist in the IT world are now certainly prevalent in the OT world. And so property owners now have a challenge. They're sort of saying, well, I need to make my building smarter, but in order to make my building smarter, I've got to be connected to the net. That now means the air gap is gone, and we now have cybersecurity risks that never existed before. So they're saying, well, in order for me to make my building smarter, I've got to resolve the cybersecurity risks. And so it's really uppermost in their mind that they've got to address this cybersecurity problem in relation to OT. Now, this next slide actually shows the enormity of the problem. You've got to make your building smarter, but you're introducing new risks. In the IT world, 35% of all spending is going towards cybersecurity to mitigate those risks. But at the moment, in the OT world, we have less than 1% spent on cybersecurity. But why? Because operational technology had an air gap, so there was no need for cybersecurity. But all of a sudden, there is now. And we have TCP/IP as the prevalent framework for the internet to come alive, and that in itself is a massive risk. So it's sort of that sort of answers the questions. Why do we need smarter buildings? Because we want an enhanced customer experience and productivity enhancements for the property owner. But in order to make them smarter, we've got to solve an emerging problem that never existed before, and that's cybersecurity for operational technology. If you actually now dig a little bit deeper, you start seeing why these problems exist. I don't know how many of you are familiar with the built environment, because although I'm talking about buildings, the application of what I'm talking about applies to any technology, any operational technology in any built environment. We're talking tunnels, stadiums, hospitals, factories. This relates to any OT. If you go into buildings, for example, I can tell you now, we have outdated operating systems. We have no automatic antivirus updates. In fact, in a lot of buildings, we have no antivirus measures at all on the OT because the air gap used to take care of all that. We have unencrypted passwords. In fact, even worse, most of the passwords are sitting on yellow stick-it notes on the computer screens of the FM office. And we have a lot of different direct and unprotected internet connections. And we have remotely accessible devices, i.e. we have a huge number of vendors requiring remote access into the building. Which then means that a lot of bad actors are now seeing that they can use the OT side of the building to gain access to the building and then create havoc. Either disrupt the physical operation of the building, implement ransomware threats to the building, or even worse, use the OT side of the building to tunnel across to the IT side. So you can see that these risks are massive and emerging in the OT world. And because of the air gap that used to exist, they weren't there before, but they're there now. So I can tell you now, property owners in Australia or down our part of the world are hugely, hugely concerned. And some of the examples that are causing them to basically not sleep at night are shown here. Now, there's three examples that I've picked on. I could have picked really hundreds, but probably the most high profile one is the Target breach that happened a couple of years ago. Over $250 million in financial loss because of that. Google in Australia just recently was hacked, and also a hospital network in Melbourne, in Victoria, in the Victorian state of Australia. And in all of these events, the common theme was that the hackers gained access to the building through the operational technology side because it's now connected to the internet. So all of this enhanced risk is being reflected in the premiums that are increasingly being paid by property owners for cyber insurance. 2015, $2.5 billion for cyber insurance. 2019, $7.5 billion. 2025, it's projected to be over $23 billion. Now, I'm sure if you track, and I haven't done this, but if you actually track the increase in cyber insurance premiums, it's directly proportional to the additional IoT devices that are going into buildings and the extra operational technology that is going into buildings. So the two things are hand in hand. And now you're seeing the perfect storm that's being created. You've got building occupants wanting more comfort in their buildings, which means more operational technology. But before you can implement a smart building strategy, you've got to solve your cybersecurity problem. But in order to solve your cybersecurity problem, an IT department now has to basically double its size, because it's saying, well, I've now got to protect operational technology that's now connected to the internet, as well as information technology. Well, let me tell you, IT departments don't have the budgets to basically apply the pricing paradigms on the IT side to the OT side. So just in a recent meeting that we went to, we could actually see people in the room saying to us, okay, we now have to protect OT like we're protecting IT, but we can't double the size of our IT department. And they asked me the question, they said, Nicholas, is it possible for you and Temped to deliver the cybersecurity solution that Temped are proposing as a service? And we said to them, in fact, that's the only way we will deliver it, as a service. And you could see the stress go out of the whole room, because the CTO of that organization knew that he just couldn't double or triple his budget on IT, and to actually solve a cyber problem that he never realized existed before. So that's the confluence of events that's actually causing us to deliver cybersecurity as a service on the OT side. Now, if we were to apply the cost paradigms that we have with cybersecurity IT on the OT side, it just wouldn't work. The reality is, on the OT side, we have a multitude of vendors accessing the buildings. And if you look at firewalls, they were always designed for human communication. Firewalls were not designed for device-to-device communication. So the moat and drawbridge solution that you see there with a big cross through it, that's essentially the traditional approach to cybersecurity. Firewalls, VLANs, switches, manual configuration. That is very costly. And it may be affordable on the IT side, but it's certainly not affordable on the OT side. And this is where software-defined networking and HIP protocol Airwalls, they're coming up with a different approach to implementing cybersecurity. So a plug-and-play approach, for example, host identity protocol being used on the Airwall switches that Temped has pioneered. This new technology is allowing us to go into buildings and implement cybersecurity on the OT side at a fraction of the cost of what is the cost paradigm on the IT side. So in terms of securing smart buildings, it's the optimal path. And we've proven it's easy to implement and it's low operating expenditure. And because we're delivering it as a service, there is no capital expenditure whatsoever. Now, what I want to explain to you next is how we actually implement the solution as a service. There's a 9-step process that we've implemented. And essentially, the other big problem that IT departments have traditionally had when we have these conversations about cybersecurity on the OT side is they say to us, okay, Nicholas, so in order for you to implement your service, you've got to give us a price. How much is it going to cost us per month? And they say, in order for you to give us a price, I guess you need us to tell you how many buildings we have and all the operational technology details in our buildings. And then they get stuck. They say, we don't have that information and we'll need to do an audit. And we actually can say to them, no, actually you don't. All we need from you is how many buildings you need to cyber secure and just a rough indication of what operational technologies you have in the building. And the beauty of the solution is that we can go to site with a Temped Airwall switch or switches, and we do a network scan whilst we're on site. We identify the OT networks to confirm the accuracy of the data that we were given. And depending on how many OT networks we find, we implement the appropriate number of Airwalls. We then onboard all of the users that are needing to access this technology remotely whilst we're on site installing the Airwall switches. We then do an assessment of what we've done. And at that point, we basically flick the switch and turn on the invisibility cloak. And essentially the whole building is now secure, and we have a basic segmentation strategy in place. So we've addressed the north-south issue, and we've got a rudimentary west-east segmentation strategy in place. At that point, we leave the building with the building secured, and we create as installed documents that map out what we've done. We then sit down with a customer and present the documentation that we've provided, and then go through with them and discuss whether we need to create a more nuanced segmentation strategy in the building. But the beautiful thing is with this solution is the building is actually now safe from threats. And we can simply have a conversation about how we evolve what we've already done. And at that point, depending on the conversation, we may go back a second time and implement an additional hip switch, or Airwall as we're calling it now. So you can see this 9-step process is a very simple way of implementing the solution. And it totally collapses the install time for implementing cybersecurity on the OT side. Now, the benefits of all this. Well, acquisition cost in this particular diagram shows you it's 25% of the traditional cost of cybersecurity. The reality is, I think it's more like 15 or 20% based on what we've done in Australia. Deployment time is totally collapsed. You can see up there that Tempert have managed to do a US university campus, 50 low-rise buildings in a week. We're averaging 1 high-rise building per day in Australia to 2. We've recently had a client who started talking to us about cybersecurity, and they were expecting to have the cybersecurity solution implemented by the end of next year. That's December 2020. We've just rolled out the Tempert network solution in 3 weeks across all of Australia, all their buildings. We're talking over 60 buildings, and we did it in 3 weeks. The system is up and running before Christmas 2019, when they were expecting to have the solution running by December 2020. The fact that we've been able to bring forward the cybersecurity solution by 12 months means that that particular real estate investment trust can now proceed on its smart building upgrade strategy 12 months ahead of time. So it's a huge, huge benefit for them. And in terms of additional headcount for IT departments, it's 0. There's no need for IT to add any more people. All they need to do is oversee what we're doing and give us access to the buildings. So I hope that sort of makes it very stark the benefits that this technology can provide. And finally, delivering it as a service, we're using a new contractual mechanism that we call technical asset service agreements, but essentially that's the as a service model coming into the built environment. And being able to bring this new technology into the building as a service means there's essentially no financial risk whatsoever, because the property owner knows all the cash flows for the term of the agreement. Maintenance, repairs, admin, remote vendor management, all that's taken care of as part of the service. The IT department doesn't have to basically employ any additional people. All they need to do is meet with us once a month, where we can update them on the progress of the service delivery. There's no CapEx. The technology that Tempert is providing us is basically a service. There's no capital expenditure to bring it in. So it's a very easy financial decision to make, which basically means improved capital management, because the property owner now doesn't have to use any capital for this. It's just a monthly fee at a fraction of the cost of what it traditionally used to mean to cybersecure technology. So that's why in Australia, delivering it as a service has proven so popular. That takes me to the end of my presentation. Thank you for listening. I hope I've answered any questions that you may have had. I know that at the end of Brian's presentation, where he'll go into a lot more technical detail, you'll get an opportunity to ask us questions. So if you have any, please feel free to put them on the chat rooms, and we'll hopefully can answer them at the end of Brian's presentation. Thank you very much.
Oh, thank you, Nicholas. That was some interesting information. A couple of things stood out to me. Just the cost disparity between IT and OT in terms of what the spend is for cybersecurity is staggering. I mean, you're over an order of magnitude different there. And the hand-to-hand relationship between insurance costs and the increased connectivity of IoT. Brilliant observations. Thank you for sharing. So we're going to move on to our next presentation now. Our second speaker, Brian Skeen, is the CTO and Vice President of Product Development at Tempered Networks. And he'll be presenting our second session, which is entitled Secure Networking for Smart Buildings. Now, Brian is responsible for leading a world-class team of engineers at Tempered, and he has a deep and successful track record of delivering breakthrough technology with an eye on simplifying complex challenges for businesses. His most recent position before Tempered Networks was VP of Engineering for Simply Measured, a social media data analytics company. Prior to that, he spent over 15 years building products at F5 Networks and was instrumental in re-engineering the company's flagship Big IP software, which has become the market's leading application delivery platform. Brian also played key roles in developing and advancing F5's powerful portfolio on intellectual property, including global load balancing technology, Big IP control plane and data plane clustering, and application fluency. He has a BS in computer science from California State University, Northridge. So without further ado, Brian, please, the floor is yours.
Well, thank you, Greg. I'm afraid my accent isn't as cool as Nicholas's, so I hope everybody will bear with me there. Good afternoon. Let's see if I do have control of the slides. Okay. I'm clicking. There we go. All right. So Tempered Networks is focused on securely networking the operational technology environment. We're doing this because the convergence of IT and OT is breaking existing security models. And that's what we've been talking about. Attempting to extend IT security tools into the OT environment is too costly, is difficult to deploy, and is far too complex to manage. And we think that a new approach is needed. And that's why we are in business. So there are about 4.3 billion human active users on the internet today. How many things are connected to the internet? So this graph depicts the answer to that. The numbers are pretty staggering. These are devices, these are not end users connecting to applications. So OT devices are often difficult to protect. Many are vulnerable because of outdated and unpatched software. Most have no ability to run additional layers of security software. Today, there are about 25 billion devices connected to the internet. But in 6 years from now, it's going to triple to be about 75 billion devices. And I'm glad that Nicholas pointed out that the cyber insurance premiums are going to triple in the same time span as well. Today's security infrastructure can't handle 25 billion, let alone 75 billion devices. And there's not enough time to completely rebuild, relay down new infrastructure to handle the scale. So IT versus OT risks. IT breaches result in data loss. And Nicholas also alluded to this. And this could be financial information, exfiltration of customer data, sensitive data for a company, including intellectual property. And this is terrible and a massive problem. And we hear about it every day. But when we talk about OT breaches and the results of OT breaches, we're talking about the loss of control of physical infrastructure, which could result in property damage and even the loss of life, of human life. So this is terrible. So smart buildings, as we like to call them, connect to networks outside the buildings themselves. And Nicholas also laid a very good case for why this is. This exposes buildings to new and evolving threats. building systems need frequent attention, it's expensive to visit remote buildings. And so vendors want to get remote access to the building management systems. And one thing that we see if you visit a lot of buildings is that if you don't connect your building to the internet, your vendors will. And in fact, they might even connect, multiple vendors might connect your building to multiple ISPs. So analyzing building data gives us great benefits like predictive maintenance and energy efficiency. This is an exciting area for innovation. There's a lot of activity. But this connects things in the building to a hostile network that they were not designed for. And traditionally, we didn't have to keep perfect records of what's in the building, or where it is, or what's on the network, or what is talking to what on the network, and should we allow that? Now, to secure these things, we scramble to do expensive physical audits and network scans to create security policies in traditional manners. And this is an ongoing challenge. So that leads us to this point. Buildings used to rely on a closed private network called an air gap. But buildings are being connected regardless of security measures and exposed to more risks than they were ever designed for. And the status quo is unacceptable, but redesigning the network takes time. And we don't even have the tools to accomplish all of the good ideas. So the question really becomes, what can we do right now? Well, fortunately, there's a purpose-built solution for IIoT called an Airwall, which restores the virtual air gap. We call this a virtual air gap firewall. So an Airwall hides your IoT network by creating a secure overlay that leverages your existing infrastructure and your existing people and teams. Harden your things with a cloak of invisibility instead of trying to apply IT measures to unique IIoT safety, scale, management, and security challenges. So firewalls, what's the difference between an Airwall and a firewall? Well, firewalls work for traditional IT systems, but are not purpose-built for IIoT. They were built to handle human application communications, think of client and server. So firewalls will have to evolve to handle IIoT scale and their different protocols. For example, tons of repetitive small data packets that are mostly fine, and broadcasted control messages that sometimes need to be crawled. Firewalls require a physical network redesign in order to centralize all the traffic in a building so that they can see the traffic. Network protection is inadequate. What we really need is device-to-device policies. This is not something that you can easily build with today's firewall technology. Device-level policy becomes absurdly complicated in a centralized firewall. And what does complexity mean? Security holes. So the Airwall restores a virtual air gap for devices, which greatly simplifies the way that we can understand and think about and manage the cybersecurity of these connected buildings. So think about reducing all the noise in the building. This lets your equipment, including your existing infrastructure, which includes firewalls, security systems, loggers, things like that, they see more of the expected data, operate more smoothly, and spend less time having to filter through the noise. So the virtual air gap results in a simpler network that's easier to manage, maintain, and extend without breaking security. I think extending the network is something that's very important here. Often we will do these expensive audits and lay down security policies, and over time, when the network needs to change to accommodate new devices and new systems, it's very difficult to keep those policies up to date. So we're talking about firewalls, we're talking about an Airwall. Let's get under the hood just a little bit. And I don't mean to scare everybody with this diagram. Now's not the now's not necessarily the time to reach for the coffee, because I'm not going to dwell on this too much, but firewalls are built using with TCP/IP in mind, which is a protocol that combines the identity of something and its location. So the IP address can change based on where something is, or based on what IP address something is given. And that is not necessarily a good thing when it comes to creating security policy. An Airwall is based on a secure protocol that is zero trust. It separates the location from the identity and allows us to orchestrate things in terms of these identities. So what this really means is that the host identity protocol sits between layer 3 and layer 4 in the network stack. And this is a conceptual diagram. What I don't mean to imply is that we're asking that everybody update all of the equipment to speak a new protocol, because that's just impossible. The Airwall takes care of this for us. So the host identity is separate from the IP address. And that's all of the security policies are orchestrated in terms of these globally unique identities that don't change. Which brings us to, how do we set up these security policies, and how do we do this at scale? So complexity being the enemy of security, main cause of security holes. Airwall policies are orchestrated entirely through a single pane of glass and expressed in terms of these unique identities. This is the central policy brain. And with an Airwall, you don't have to log into something in the cloud that you don't own, that possibly has other tenants' data on it. It's not like as a service. You get to own the orchestrator, this central brain. It can be hosted. You can host it in a data center. This could be on a physical machine, running in virtual, or running in a public cloud. And it's so easy because, and I can prove that because most or many of our Airwall customers in the OT space are not absolute gurus when it comes to networking, yet they can be productive on day one, connecting things across the WAN. So as Nicholas referred to, the Airwall can go into the buildings very quickly. And it's critical to be able to do this. We have to be able to deploy in very many places, in very many environments, and in vendor laptops and vendor machines. Exceptions to this would create security holes. So we have to have platform ubiquity. An Airwall can be a gateway that protects devices, which we call an appliance, or it could be an agent that protects a single client or a server. Airwall software agents install on major client server and mobile platforms as seen here. The Airwall appliance runs in physical, virtual, or cloud environments. The appliance uplink can be wired, Wi-Fi, or cellular, or a combination of those. The appliance provides port density options. The ports can be configured into isolated port groups and are VLAN tag aware. So an Airwall appliance has intelligent link monitoring that finds the best uplink at the moment. It's actively monitoring these. And for very remote locations, we even offer a dual modem Airwall appliance that can actively monitor 2 different cell providers and intelligently pick the best one. So let's talk about a couple of the main goals for smart buildings. One of them is connecting the building analytics to the analytics server. So this is a very common need across all buildings. So and the reason for this is that the cybersecurity as a service provider wants to do predictive maintenance to become a holistic, essentially a building doctor, is the term Nicholas has used, rather than reacting to failing components. The benefits are great, but the networking part here is a real challenge and opens up the building to attack. So for example, there are many ways to get this data to the analytics server from the buildings. The analytics server can pull for the data like this, speak some protocol over HTTP. The request to go into the building from something external is surely going to be blocked by a firewall, if there's a firewall there, which means that you must add rules to the firewall and go touch that and create a policy to allow the analytics server to get into the building to talk to the BMS, or rather, most likely to the entire BMS network. So that whether that's what you want or not, that's what will happen. So in the other direction, you can set up a BMS to stream data to an analytics server and push. So that looks pretty similar, and it's going to be blocked by a firewall upstream from the analytics server. So you have to go to that firewall and allow that particular BMS in the building to be able to get through to this analytics server. So this involves IP addresses. And this is very, very difficult to maintain. And we're really talking about, 60, 80, 100, maybe even 1,000 buildings where this is all spread out. And it's more than just a BMS server. There's multiple things in there that are producing data. So fortunately, though, with the Airwall, this entire hub and spoke policy can be implemented in 2 lines in the policy. That the analytics server is allowed to talk to the group of BMS servers across all the buildings. So a second very important goal is to provide this vendor remote access. And as you can see, the cyber as a service has to load balance many entities and priorities to provide remote access for vendors. There's a lot of moving parts. So remote access problems are commonly discovered to make matters worse while troubleshooting something else under pressure, probably at odd hours, and solving them needs to be rapid but maintain security. Otherwise, typically the vendors may even have to call somebody up on site to bypass the firewall or bypass whatever measures are in place to reach the internet temporarily. And if you're skeptical, then I was skeptical too until I've seen this many, 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 many times. This is just happening. So this is really hard. It's really expensive to maintain all of the ACLs and rules in the firewalls and the security apparatus for especially remote mobile vendors. And it's not just a company, it's the individuals in that company. And these technicians may change. They may no longer work for the vendor at some point. So how do you manage all of these users accessing all of this equipment across all of the buildings? So fortunately, we have the Airwall, and it provides a comprehensive vendor access management solution that provides a lot more than we've talked about here, including the onboarding, the offboarding process, multi-factor authentication for these users, tracking, reporting, and even monitoring the Airwall edge appliances to detect when somebody unplugs the cable and borrows the internet connection effectively. So what enables these previous use cases to be simplified by the Airwall? And one of the main things is this Airwall relay. It's totally based on the separation of the location and the identity. Without that, we would have the same complexity. We wouldn't be having this conversation. It would have taken until December 2020 for the installation to occur that Nicholas referred to. So the relay splices these encrypted tunnels that the Airwall edge services create between each other. They can be run in the data center. The relays can be run in a public cloud. The only real requirement is that they need one public IP address. And these scale horizontally. In the Airwall, you just simply say one group of Airwall edge services can reach another group of Airwall edge services using a group of relays. And it's really that simple. So if you need to scale it, you can just add more relays, and the edge services will use things like round trip time and latency and the loads on the relays to balance the load and to continue to get tunnels made. So another important point about the relay is it does not decrypt the traffic. That's very important to many of our customers, because we can deliver connections that remain secure and point to point. And they own the relays. They don't have to pass this data up into some cloud where they have to trust a vendor to do whatever happens and apply whatever rules. So this technology allows the Airwall Edge services to extend deep behind perimeter security apparatuses and not need to touch them in order to change the network. So for buildings specifically, this eliminates the firewall changes. It enables encrypted peer-to-peer from, say, the analytics to the BMS server, not network to network. And it simplifies vendor connections regardless of mobility, their ISPs, Wi-Fi or cellular choices, doesn't matter. So Airwalls are deployed in many diverse building environments, and here's just a few examples. At Penn State in the US, they needed to separate the IT from the building networks and separate the students from these networks after security breaches caused physical damage. So their main needs were met because they were able to deploy 50 buildings in 5 days. That's 640 total buildings protected and connected. And then they noticed an immediate reduction in the amount of noise in the network and in their firewall logs, something that they hadn't expected, but they were drowning in trying to respond to alerts, many, many false positive alerts. And they immediately reduced the noise on their logs. So that was one of the big benefits. Grosvenor Engineering Group, Nicholas's company, wants to provide cybersecurity as a service for their existing customers and new customers, meaning that they manage vendor remote access, that they connect the BMS and other systems in many buildings to a central analytics platform, and are able to act on that data to provide predictive maintenance and advanced analytics to become more intelligent, holistic about their building management. Brookfield Properties needed to separate IT from the building networks after an audit. They got some audit results and they needed to act. So very important to them was multi-factor authentication, not only for managing the policies in the conductor, like administrative access to the orchestrator, but also to authenticate users using multiple factors to get onto the network itself and have that centrally managed. So the Airwall supports anything that speaks OpenID Connect, like Okta or OneLogin or something like that. So they also needed, they have a big scaling problem. They had a lot of east-west broadcast storms, and they're deploying Airwalls in very large buildings with, I'm told, potentially millions of talkers, of hosts in those buildings, which is just a staggering, staggeringly complex thing if you're trying to create a blacklist. But the Airwall, of course, operates with default deny, and you create a whitelist between devices. So there's a maritime customer that we have. If you think about a cruise ship, it's really just a big mobile 30-story building lying on its side. So one large cruise line that, as our customer of ours, needed to separate some of their old systems from newer systems that they were installing in the ship, and separate all of that from the IT network on the ship. And one of the things that got us that business is that we were able to actually deploy at sea, which is really unheard of, with no downtime. So, I mean, we've been talking about buildings, thinking about buildings, being classic buildings. But if we extend that, the concept of a smart building really goes beyond the traditional brick and mortar building. Smart buildings today support the idea that a structure, like say a skyscraper, a cruise ship, a factory, a stadium, something like that, is fully automated, controlling various operations. I think Nicholas mentioned 40 plus, 46, something like that, such as heating, air conditioning, lighting, et cetera, that these systems that are connected to power. This structure can be mobile, not fixed to any particular location, but the problem is very similar or the same. I mean, mobility just adds some complexity to the whole thing, north-south. So a smart building utilizes sensors to gather data about activities taking place within and around the structure. It manages them according to the structure's function and needs. In summary, an air wall provides a lot of benefits with today's buildings and tomorrow's buildings and networks. So the transition to future network architecture is very expensive. It takes a long time. We have a solution right now that can be deployed in about one large building a day, or in about, say, 10 buildings a day in a university environment, for example. It's extremely easy to try it and install and to do a POC. So thank you for being part of our webinar, and I'll turn this back over to Greg.
Thank you, Brian. That was a tremendous amount of information. It's almost mind-boggling. I think the audience is sharing that sentiment, but they are not without question. So I think it's that time that we want to transition now to the Q&A portion of our session today, so we can entertain some of these questions that are coming in, and feel free to keep submitting them as we're going along here. We've got several minutes. Several of you have asked about content from today's session, and yes, that will be available after the presentation today. You'll receive a link to download that. And for your continued submissions, we have two options. You can continue to send them into the Q&A tool here. Please don't send them in through the comment portion. And then you can also use the hashtag ICS_IIoT. And that will get them onto the Twitter platform, and we will carry the conversation over there post-event. So let's kick it off with a question here from Sri Kumar. This is, how safe is it when we adopt cybersecurity as a service?
Greg, I'm happy to answer that one.
Go right ahead.
Given the experience we've had in Australia, what I can say is that the installations that we've done has been with very large property owners with entire departments focused on risk management. So we've gone under the most rigorous risk assessments that you can imagine. And it wasn't just, it was commercial risk, it was technical risk. And in all of those discussions and audits essentially that were done on us and tempered, we passed with flying colours. Essentially, what tempered and the technology has done is actually taken away risk, because it's taken away the complexity of setting up cybersecurity, and it's basically automated a lot of those processes, which has allowed us to get the cost benefits and the time benefits for installation. There's been rigorous penetration testing done on what we've done in Australia and New Zealand. So all I can tell you is all those tests were passed, and we're dealing with very large organisations. So they deemed the service very, very safe, which is why they adopted it.
Got it. Well, thank you for that. There's probably, I guess, a follow-on question to that. If I can, it says, what happens in case the vendor or the partner systems are hacked? Who's providing cybersecurity as a service, and how strong are their systems?
Ron, I don't know if you want to,
Oh.
or if you want me to. I'm happy to.
You want to try that, Nicholas?
Yeah, look, the reality is we've also provided a scene overlay service to this, and we're actually talking to Tempert about fully integrating that service in. So we're actually monitoring what's going on as well. And the whole idea is that it's a complete solution. So, and we're essentially guaranteeing that people will not be hacked. I mean, there's a minor possibility. You never know what you don't know. But in terms of our ability to respond to threats and assess threats as they're evolving, it's second to none in terms of the service and how it's packaged together.
And I'm going to just tag on and say, from my personal experience visiting many different buildings, many different customers, you know, having somebody who knows the system very well, intimately, and has best practices, and can provide transparency through the reporting to the end customer, I think is the right way to go. I think it's a good combination.
Got it. Well, thank you both for that. Jimmy's got a question for us as well. It says, how are the Airwalls different from a closed VPN network?
A closed VPN network is probably based on a protocol like IPsec or SSL. And it is pretty inflexible. So the counter question, I would just pose a question to you, which is, how difficult is it to handle mobility and dynamic environments where IP addresses may not be known ahead of time, where things move around and are given IP addresses dynamically, and handle environments where there are intermediate systems that may depend on IP addresses as well. So the fundamental difference with the Airwall is that it's based on that protocol separation that separates location from identity, and that we can do a lot of things because of that. The IP addresses just don't matter, and if they change on us from a technical perspective, we can rebuild the tunnels we can use. NAT is fine. The outer encapsulation is UDP, if that gives you any hints. And if you think of, you may know what I mean when I say ESP tunnel mode IPsec. So something that's very NAT friendly for the data plane, and that is orchestrated world class based on something that's not changing, meaning the identity.
Got it. Thank you, Brian. Jose's question is, wouldn't a new layer in the stack add to the complexity per device with hundreds or thousands of them in mind?
Yeah, I love that question. I totally agree. Adding a new layer in the stack doesn't simplify things. If anything, it could complicate things. And in terms of Tempered and the Airwall, I think an Airwall could be built on any protocol. It could even be built on top of a existing protocol that does not do a good job of separating IP address and identity. It'd just be a lot harder to do. So adding a protocol into the network stack doesn't really solve anything. It gives us another tool. And without the orchestration that we've built, which I'm not sure if I emphasize this, but if we didn't orchestrate host identity protocol, I don't think it would be that valuable. More than half of our effort goes into the orchestration.
I think, Brian, yeah, one other thing, I guess, from a non-technical perspective, one of the things, and I'm going to talk just about the simplicity. One of the things, because we did a big search all over the world to settle on Tempered as our cybersecurity partner. And the reason for that is because one of the attractions of the technology was the fact that we could go into any building with any operational technology set up, any firewalls in place, and it didn't disturb any of that technology. it basically it was, and that's why we call it an invisibility cloak, because it essentially cloaked the existing infrastructure. And because of the orchestration that Brian's talking about, it's actually very simple to manage and maintain. But the point being that that's the huge attraction of the technology. You don't have to change your moat and your drawbridge. You can leave all the existing equipment and infrastructure as is and simply lay this over the top. And that creates massive simplicity. And it's what's made this whole solution viable.
Yeah.
Got it. Got it. Okay. Well, thank you. Now, Daniel's got a question. He says, how does this align with the Purdue Enterprise Reference Architecture? So would you like to tackle that one, Brian, or is that?
I think that's a Brian. I can certainly give my two Bob's, but I'm sure Brian.
Well, I don't have that memorized, and I can pull that up, and I know what it is, but I'm not an expert on the Purdue reference architecture. But so I think I could maybe take that one offline and provide something with the materials that are provided.
Perfect. Well, we will address that offline then, Daniel. Thank you for the question.
One other thing, while I've got you, Greg, I do want to make the point, the as a service concept, and no one's asked this question, but I might as well answer it myself and put it to everyone out there. The way the as a service is provided is the customer's environment is totally isolated from Grosvenor's operating environment. So the way this whole thing works is the conductor is dedicated to a particular customer. So it's essentially their tempered solution, their Airwall solution, and it's not mixed with any other customers. So, and that's very, very important for all these big customers down in Australia. That they've got, essentially it's their own portfolio cybersecurity service.
Okay. So Shrikumar's got another question. He says, how will the patch management for OT system be taken care of if the OT systems are from different vendors?
Well, that's I can tell you now, it's very poor. One of the things that we're also doing as part of the service that we're providing is basically creating a audit process to identify how those things are performing. But that's quite a separate issue to the invisibility cloak that we provide to the building. But it is a complementary service that we're delivering, where we're auditing all the vendors and the patching infrastructure that they have in place, and also doing some monitoring of that.
Got it. Okay. Perfect. Thank you. Now another one came in and says, we often experience poor network performance due to broadcast storms. Does an Airwall help in this situation?
Yes, the Airwall helps because it's default deny, and you intentionally have to whitelist which things should be talking. It's very simple to do that and to maintain that with device groups. So we work on devices, but if device to device communication is not explicitly whitelisted, it just doesn't happen.
Okay. Now, how about the HIP protocol? Another question around that. Is it proprietary or vendor agnostic?
No, it's RFC proposed standard approved. We're already on version 2. It started, I don't have it memorized, I think maybe 2004 or 2005. The original drafts were submitted to the IETF, and they floated up through the drafts process and were approved, I think, in 2011. So it's a standard protocol. It's a proposed standard. But like I said before, just having the host identity protocol doesn't give you an Airwall. It's all the orchestration of identities and policy on top of that, plus the innovations like the relay and the clients, the ubiquity of the platform, the ability to install on handheld mobile devices, on laptops, and extend the Airwall edge into all environments that makes this a useful security solution.
Okay, now we've got a question here from Daniel. He says he missed in the use case 2 under the goal building analytics slide how the Airwall simplifies the push-pull concept architecture. So I'm not sure which slide that was. Do either of you recall?
Is it my slides?
Yes,
the use case. It's the use case that I showed where we were connecting the, for example, like a SkySpark or other analytics server to a Tritium or Johnson Controls or some kind of a BMS in the building or in several buildings. Could you repeat the question for me?
Sure. So he missed it in use case 2 under the goal building analytics slide, how Airwall simplifies the push-pull concept architecture.
Airwall provides the connectivity through the network. That's its main job. It's not, if I try to understand that question, I think maybe it's around something like, do we provide proxy or protocol awareness and maybe WAN optimization or reduced chattiness or some of these techniques that I can imagine would be useful, say with an OBIX protocol proxy. The Airwall, we tempered don't provide that. I happen to know that Grosvenor has built a box that could sit next to a BMS and do all the queries and walk the data locally, pull it all out, and then reduce the number of round trips over the WAN to get the data back to the analytics server. But, you know, so we're more of the networking piece, and solutions can be built on top of that.
Yeah, it plays a neutral role in the whole process.
Okay, well, thank you both for that. Daniel, if that didn't answer your question, feel free to send something else in to us. We've got one here, another one from Sri Kumar. It says, do you carry out VAPT for OT systems? If so, do you carry out in production systems?
Sorry, can you repeat that one again?
Yeah.
Sure. It says, do you carry out VAPT for OT systems? If so, do you carry out in production systems?
VAPT, I'm not familiar with that acronym. Yeah. Nicholas, do you know?
Yeah, no, neither am I. I haven't heard of that one before, sorry.
That makes 3 of us. So Sri Kumar, if you want to shoot us a note as to what that stands for, we'll take another crack at it. Now Thomas has a comment here and a question. It says, as we all know, there are 2 very important factors in smart buildings, a good network connection and an impeccable power supply. There's a large number of loggers, etc., that are also protected by a classic firewall. What contribution can the Airwall make here, for example, in the energy supply, or how helpful would it be to introduce the producer side to the Airwall topic?
Oh, that's a really good question. So in terms of the tempered Airwall, which, you know, I'm using the Airwall with lowercase a here because I think an Airwall could be potentially looked at as a new kind of a thing that other people could make an Airwall, for example. We have models that provide PoE out and we can take PoE in, but we have not tried to condition power or become a better, like a UPS or a battery or something, if I understand the question right. I mean, it's a very good idea. And that's something that we should probably look at.
Okay. Very good. We have, let's see, here's a question from Adil. It says, does 5G technology work well and safely with the Internet of Things? It's kind of a broad question here.
Absolutely.
Well, I just pick up this textbook on my desk that I've got called 5G Security Comprehensive Guide. And no, I actually do have a textbook in my hand. You know, that's a loaded question. I think that's actually, that would be a good topic for another entire webinar, another presentation. I can tell you that in a 5G network right now, if you took our product, Tempered Networks Airwall product, and used our cellular options, then they would operate in 4G, in a 5G network. That's what would happen. So they'll work, they just won't go that fast. The thing about 5G too, if I understand right, you know, the scaling, and then especially scaling up the bandwidth. So in an OT world, up till now, it's interesting. When I was at F5 Networks, everybody asked how fast it would go. When I'm at Tempered Networks, not that many people ask how fast it goes. I mean, in an OT world, the data that is being passed around is pretty, you know, the scale of the data, the bandwidth requirements is different. It's more just the scale of the concurrency and the number of things that get you. So in terms of Airwalls, we have a 10 gig Airwall edge appliance, but that's not necessarily what we put in every building. So, you know, right now we're just looking at compatibility, and we're trying to figure out, we're actually trying to figure out 5G just like everybody else is, so.
Well, very good. Well, that sounds like it's a good point to wrap up. So I want to thank everyone for taking the time to join us today, and special thanks to our speakers, Nicholas and Brian. And stay tuned for other educational webcasts brought to you by IIoT World. Over the next couple of months, we have the following summits scheduled. We have World Expo 2020 site, a blueprint for future smart cities. That's January 15th, 2019. We have Simulation Digital Twin Solutions on January 30th. And please save the date for a special IIoT World Global Day, June 30th. That'll be a full-day virtual summit dedicated to accelerating the rate of adoption of industrial IoT, so you won't want to miss that one. You can also secure briefings with our analysts or co-founders during the upcoming events or over the next couple of months. We'll be at Distribute Tech in San Antonio, that's January 27th to 30th, 2020. ARC Advisory Forum, February 3rd to 6th. And Hanover Messe 2020 on April 20th to the 24th. Special thanks to our sponsor, Tempered Networks, for this educational session. If you have a suggestion for a topic or otherwise, we always welcome feedback, so please drop us a message and let us know. And if you like what you heard today, we invite you to subscribe to our newsletter, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our program for today. Thank you all for joining us.